Welcome to the Control Engineering webcast, Plant Data and Connectivity, the Building Blocks for Industrial Transformation, sponsored by PTC. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. Here are some tips to get the most from today's webcast. If you're experiencing issues from slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get back to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type questions for our speakers in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded and you'll receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents also will be available with the on-demand version of this webcast. Now I'm happy to introduce today's distinguished speakers. You see the bios up on your screen. I'm just going to go through a little bit. Patrick Fetterman is a research analyst with LMS Research, providing collaborative coverage across industrial analytics, manufacturing operations and technologies, industrial transformation, and the industrial Internet of Things. Ray Levy is a principal applications engineer with PTC and focusing on Kepware industrial connectivity. Ray joined Kepware Technologies in 2014 and came to PTC with its acquisition of Kepware in 2016. He has prior experience in shipbuilding industry, integrating complex network control systems for various other control systems. So, Patrick, please go ahead with the first part of the presentation.
Thanks for that introduction, and thanks everyone for attending today's webinar. I'm excited to be talking about this topic today, as I'm a little bit of a factory data geek. It's really near and dear to my heart. All the research I'm going to be quoting today is brand new in the last few weeks, in the last couple of months, and some of it's being shared for the very first time in this webinar. So excited to dig into that today. We'll start by talking about my agenda. I've got some really great information to share. First, I want to give you an introduction to LMS, who we are, and the area of focus for us. Then I'll dig down into what we call industrial transformation, giving you our view of digital transformation in the industrial world and how we track and analyze what's happening there. From there, we'll identify what makes a company a leader in industrial transformation, separating out the people that are seeing real success there from the laggards, and what those companies are achieving with their efforts, what they're doing different. We're always trying to identify those leaders and what they're doing differently from everyone else. Once we have that foundation established, we'll take a look at what's going on with plant data and connectivity, as we've seen some really fascinating changes here over the last few years. And what those leaders are doing is very different than how other companies are operating in this space. Most importantly today, we'll spend a little time talking about the measurable impact of those trends. What happens to your operations when you start collecting and connecting plant data and using it to improve your quality, your throughput, and then all your other operational KPIs. Then I'll finish up with some actionable recommendations for companies who need to start moving ahead in their industrial transformation. So let me start by telling you a little bit about LMS Research. We're an industry analyst firm based in Cambridge, Massachusetts, although I'm based in Detroit. We focus on evangelizing and driving industrial transformation. In fact, we're launching the IX event later this year, which you can find more information about at theixevent.com if you're interested. At LMS, we look at how emerging technologies like these IIoT technologies can be used to transform an industrial business. It's focusing especially on factory or plant operations. This includes everything you might hear called IIoT platforms or tools, or Industry 4.0 initiatives, which are really different names for the same approaches that we're researching. So we look at everything from the perspective or through the lens of people, processes, and technology. And we conduct primary research with your peers, the people that are doing operations and management in industrial companies, to understand how all of this is impacting their business, and to sort out kind of the fluff about technologies from the real world applications and the measurable ROI from these technologies. In all cases, as I said, we try to identify best practices, what the leaders are really doing differently, and communicate those via our research reports and events like this webinar. As I mentioned, I'm going to be talking about some of those best practices today. Unlike other consulting firms or other analyst firms that work primarily with the CIO, we have a framework at LMS that provides guidance across multiple areas of the industrial business, analyzing everything from the highest level strategic objectives and plans through the building of operational architectures all the way to solution selection and implementing change management. And so really kind of top floor to shop floor here. But again, we focus on the plant and factory operations and how those are being impacted by and are driving industrial transformation. Interestingly, you'll hear me revisit this a couple of times today, we've seen a trend of CIOs getting more and more involved in operations technology, which was really unheard of before then. There was this clear demarcation between technology used in offices and technology used in plants, with little or no crossover between the two. That's a big change we're seeing in how companies operate. And you'll hear me talk about that several times today, and I'm calling it IT-OT Convergence. Our analysts at LMS are veterans of various industries across discrete batch and process with deep expertise in subjects like Quality 4.0, environmental health and safety, the connected worker, and more. My area of expertise is really industrial analytics and related technologies in the factory, including all the data technologies that empower analytics, things like databases and data lakes, data models for OT data, stuff like that. Okay? I'm broadly focused on discrete and batch manufacturing with a little process thrown in as well. I am a Detroit guy, so I'm heavily automotive, though not exclusively, but I do tend to focus more on heavily regulated industries like auto, A&D, food and bev, et cetera. But again, not exclusively. So let me dig into the recent research that I'm going to talk about today. So the way we do this is we execute a series of these global surveys on the usage of industrial technologies and related topics, again, that people, process, and operations viewpoint. We usually have around 300 valid responses for any one of our surveys. This one's got 275. And by valid, I mean something very specific, right? We're talking to executives on the IT side and the operations side, on the manufacturing side, all the way to plant managers. So people that are responsible for operational technology and operations across the three primary industry segments, right? Process, batch, and discrete. We watch for trends across those multiple surveys, not just individual surveys. We ask some of the same questions around performance and KPIs in every survey. We look for trends across that. And we divide companies into leaders or high performers and followers based on those common operational KPIs or on other, based on other criteria. And then we look at, again, what the leaders are doing differently. That's the basis for what I'm going to talk to you about today. Brand new research that I just completed 2 weeks ago, and you're the first one to get a glimpse of those results. So first, let's talk about identifying the leaders. In our most recent survey, the one that this is based on, we asked companies to give us a snapshot of their big initiatives, right? How are their programs perceived within their organizations, whether they called it digital transformation, Industry 4.0, et cetera. We use that data they provided us to identify the companies who are reporting success already in their programs. That's 30% of companies reporting that they've been making progress and are seeing value from their programs. And we compare that data, their responses to the rest of the survey, with the companies who are reporting they're in the early stages and are not quite seeing value yet, and a small group, 15%, who are reporting that their programs are stuck in pilot phase without any progress. You may have heard this term in the industry called pilot purgatory. That is that 15%. And that has been consistent within a percentage point or two across the last few surveys we've done. We cross-reference those assessments against other kind of very concrete KPIs and other assessments to confirm their status, that they really are leaders and that they claim to be. And then we look for where they're seeing ROI, cost savings, or other advantages. Of course, we're most interested in the differences between leaders and followers. What are the leaders doing differently, and what are the traps that some of the followers or those stuck companies have fallen into? So let's kind of start with the foundation here. So again, this key finding, most of the, so you're seeing that the leaders are putting operational goals first and letting that technology drive the, letting leaders putting operational goals first and letting that drive the technology decisions instead of vice versa. So let me connect that up to the plant data and connectivity topic that we're talking about today. Most of the industrial transformation use cases that lead to big step change improvements need a digitally connected plant. This cannot be just a series of kind of ad hoc connections, one-offs that are done for a single purpose. There must be a real plan behind this, right? A digitally connected plant means both a robust operational architecture and an enterprise data model, deciding in advance what data you need, in what formats, for what applications, and what time frame. An architecture and data model like this requires a strategic vision for the plant and includes not only OT assets, sensors, and systems, but also often enterprise systems and data sources outside the plant. For example, data-driven prescriptive analytics is one of the key technologies used in industrial transformation. By leveraging this use case, right, for prescriptive analytics, manufacturers can predict asset maintenance and operational bottlenecks across multiple plants. But they can also gain insights from the analytics model to get instructions to prevent or resolve these issues. So we go one step further than just predicting to addressing those issues as well. But enabling this use case requires data transfer from the assets, sensors, from PLCs and other control systems driving those assets, maybe from SCADA servers controlling the PLC and HMI, maybe from the scheduling system, potentially even from the MES or ERP system to look for correlations or causations of the bottlenecks and to examine costs. All of this comes at a cost, but the first step is to build a plan to connect things. Our key finding here is that companies have already made this step. Those who have connected plant data and have started to combine it with corporate data have achieved a real competitive edge. They perform better across a pretty wide range of operational KPIs, but they're not just sitting on those advantages either. Once they get to a fully connected plant, they're able to envision entirely new ways to use that data. We've heard plant managers and other people say things like, I didn't know I could do that. I didn't know that the data to figure that out was available. And that's happening very rapidly. We've been saying for a while that we expect these advantages to compound over time, and we're really starting to see that happen for the leaders already. Earlier on, I mentioned IT-OT convergence. When we asked companies about this recently, we learned that it's happening more rapidly than we had thought, at least among the leaders. It wasn't too long ago, really, that operation guys would laugh when asked about IT guys. Those are the guys in charge of printers and servers, but they don't know anything about what's going on in the plant, right? I can't tell you how many times I heard that almost exact quote through the years. However, as the use of plant data grows, we're seeing IT starting to join in with the OT teams to bring both sets of expertise to bear on their challenges, on all the issues. To start leveraging the plant data, it really requires these two teams to work together. As you can see on this chart, more than half of the leaders are reporting that these organizations are already fully integrated, and they're working on both legacy and industrial transformation systems. Among the followers, however, it's only 29%. And if you look higher up to the middle, another 29% of followers are saying that they're still completely separate organizations. So as I mentioned earlier, we at LNS, we see a fully converged IT organization as one of the hallmarks of successful industrial transformation, and also as one of its enablers or drivers. More importantly, really, this convergence of IT and OT has led to these new use cases that I talked about earlier that can leverage the combination of plant data and corporate data for advanced analytics and other applications and use cases. Now, I talked about how early analytics or early IIoT use cases were asset focused, right, around predictive maintenance, and required connectivity only for those assets, really. That's all that was demanded. But today's newer kind of broader use cases are more focused on broader operations and processes. And thus, you can see they need connectivity not just with the assets, but they need connectivity, communications, and even interoperation among systems and assets across both the IT world and the OT world. Companies who are behind in this area are really at risk of falling even further behind their competitors from an operational point of view. Now, what we've seen in many cases is what we think of really as a recipe for disaster. This one finding up top, 45% of manufacturers don't even have a definite list of connections in the plant. They just don't know what's going on. And that's a recipe for disaster, right? Plant managers do understand the value of plant data and connectivity. However, we've seen this long history of ad hoc connectivity solutions. And those ad hoc decisions have created kind of long-term challenges. So let's take one hypothetical scenario, a typical plant, right? The plant manager needs to connect a couple of machines for a new project. So he gets together some control engineers, a plant manager, and a couple of technology people. They put their heads together to figure out exactly what machines and systems need to be connected and what protocols those machines support. They execute on it, and that's it. But many of these projects are really very limited in scope. They're trying to do one specific thing, solve one specific problem. And so that design for a very limited use leads to these kind of fast ad hoc connections without the need to seek approval from outside resources, from corporate IT, from any other groups. But that also means any future applications beyond the limited scope of that initial project are going to require these connections to be completely redesigned. Right? For example, a new MES or MOM implementation may require more detailed data outputs and more sophisticated controls. Right? This ends up requiring kind of duplicated work, rip and replace of poorly documented or poorly executed systems, and can really result in chaos. Right? So we strongly recommend building a comprehensive plan from the ground up for connecting these systems together and avoid these ad hoc connections at all costs. You may be thinking at this point that, man, those companies out there that decided 5 or 10 years ago on a single set of controllers, that have a homogeneous factory system and common platforms, they must have a big advantage over everybody else. But the truth is, those environments are really incredibly rare. Instead, what we're seeing is that virtually all the plants out there have a mix of systems, both hardware and software. No surprise there. We've been seeing this grow more and more over the years. Even if companies started out with a plant as a completely homogeneous environment when it was first stood up 5 years ago, 10 years ago, 20 years ago, it is now really a very heterogeneous environment. And when you're talking about global organizations with dozens and dozens of plants, the challenge is even greater and the complexities are much higher. So both inside the plants and among technology vendors, we're seeing this realization has settled in, that companies need to embrace an ecosystem approach to connecting everything together. It's very difficult to say, I'm going with this one connection all the way through, or this one protocol all the way through. And we've already seen IT and OT vendors start partnering with each other to provide solutions in this space that can understand both the complexities in the IT world and speak the OT world language as well. And we see that as a very positive step forward in the industry. Now, a majority of the bigger companies that we've talked to out there today, they employ a structured framework for their manufacturing systems based on the kind of older ISA 95 enterprise architecture. This architecture enables a pretty structured transfer of data across 5 different levels, right? And you see them numbered here in the chart. And that made it easier to query results from these old centralized databases and data warehouses. But it's been a big cause of this gap between IT and OT worlds. And companies have been using this whole structured architecture approach for corporate planning, but operational stuff for daily production, and there's a disconnection between the two. So now newer technologies like the cloud and edge computing and IoT gateways are disrupting this structured framework. And now we're seeing data transfer and processing in several different places. For example, edge devices can perform pretty simple computations right at the asset level, right on the factory floor, right next to the machine, for example. And that can reduce latency and enable real-time insights into performance. And when you're talking about predictive maintenance in particular, that real-time notification makes a big, big difference. So we've seen manufacturers deploy a bunch of these edge devices where it doesn't make sense to send data back and forth to the cloud every time, right? So a single factory might have a handful of these spread around, but they're limited, right? It gets painfully complicated and expensive for these edge devices to perform really complex computations and do sophisticated analytics because they've got relatively smaller processing capabilities, right? They generally can't capture and store much data either, so they're really focused on a near real-time processing. So using a combination of edge and cloud computing provides a powerful kind of 1-2 punch, right? So the real-time stuff and the more sophisticated, complex modeling and analytics in the cloud. And this is where kind of connectivity solutions come into play. These connectivity technologies enable the edge devices, cloud device or cloud connections, assets, and IT applications can all be integrated and connected together without the need for separate software solutions across each one of these platforms. And that really eliminates a lot of the deployment times that were required previously here. Now, most of the IX, or sorry, industrial transformation use cases we talk about build on this idea of ubiquitous data and analytics, right? Analytics everywhere, data everywhere, bring it together when you need it. So our research on this topic points to a separate analytics-centric architecture that is sprung up kind of parallel to existing frameworks. This combination of these parallel architectures provide plant engineers with what they need at any given moment, a more flexible but pretty robust operational architecture to run analytics at any level they need to, at the edge, on-premise, including corporate data, in the cloud for really powerful AI-based stuff. If you want to learn more about this whole operational architecture, you can ping me afterwards. We've got a couple of different publications on this. So I'd be remiss if I didn't speak for a moment about cybersecurity. And it's still one of the most serious challenges for this newly converged world. The good news is that new OT systems have security built in. The bad news is legacy systems generally do not. I can't tell you how many times I've heard plant managers point out that any data leaving the plant isn't secure, it's prone to cyber attacks, and that's why we don't like sharing plant data outside of this secure network here, right? And why we don't allow anybody inside the network from outside the company. And there's some justification for that, right? The amount of unplanned downtime because of a PLC programming error or in some cases a data breach supports that kind of guarded mindset. But the kind of root cause here is that there's not established standardized protocols and communication layers within the plant. There's not an operational architecture that says who gets access to what data is needed, what data can flow where, et cetera. So the latest communication technologies, the newest stuff, including networking devices, smart PLCs, and a lot of these smart assets, are working with secured connectivity protocols, which is great. However, I would say this is another reason to pursue a converged IT-OT organization. Converged IT-OT security is a new requirement that most companies aren't yet ready to face. We could spend an hour or two or a couple of days really talking about cybersecurity, but I just wanted to make sure we touched on it here and we weren't so pie in the sky. It is a real world concern that companies need to take into account when they're building out their architectures. So what we end up with is that plant data connectivity is really a required step to enable industrial transformation. And companies need to act on it today to prevent falling behind their competitors in terms of performance, including financial performance. Recognizing that many plants today really do have a limited set of connectivity, manufacturers have to start thinking about connectivity not on an ad hoc basis, but moving it to a strategic value basis, thinking about it from a broader planning point of view. And it really needs to be strategically connected to enable broader industrial transformation, to enable all those use cases across the whole operation. So this is a list of characteristics we think that a robust data model and the robust operational architecture should have. You got to be able to connect with PLCs and other plant level assets, and that's got to be automated, right? Automation for data, not just automation for operations. Got to be automated and moving as quickly as data moves, right? You got to speak multiple protocols today. There's some great products out there that speak multiple protocols. You can see this at your leisure. I don't need to go through these one by one, but we are seeing more and more solutions that are intuitive to use directly for process engineers or manufacturing engineers without the need for data science to get involved, without control systems engineers to get involved as well. And those are really very, very powerful solutions today. And finally, let me end up with my recommendations for users out there. So as we know, the IoT is a really transformation technology enabler that is fundamentally changing manufacturing operations, especially operations, via this IT-OT convergence, the analytics running on plant data, et cetera. There's a lot of big things that are happening now. Deployment of these technologies needs to be raised to its strategic level with a true corporate vision behind it, right? Not just on an ad hoc one-off basis. That is how companies get stuck in pilot purgatory. It's really got to be thought of as a long-term investment. So the three key recommendations here are build a cross-functional team that owns plant data and plant connectivity. It's got to understand, that team's got to understand both IT and OT concerns. And if you have not converged your IT, OT organization, this can be a big step in the right direction. Once you have this team in place that understands both sides of the fence, they can collaborate, make better decisions, and create a holistic vision for how to use this converged data down the road as well. Second would be embracing the ecosystem, right? Recognize that there's no single vendor that's going to provide a complete industrial transformation suite. So you really should not be afraid of a multi-vendor ecosystem with some best-of-breed hardware and software that connect and interoperate with each other. And finally, again, I've touched on this several times today, future connectivity problems should not just focus on OT connectivity or on ad hoc basis, but they need to be driven by the use cases for future deployments, right? And looking at from both the IT and OT point of view, a converged data model is really a major enabler of industrial transformation, including things like analytics, including AI and machine learning. So if you need to get the data connectivity right first before you can build all those other kind of life-changing and operational changing systems out there. Thank you, everyone. And again, thanks to PTC for inviting me to speak today. Sorry about the little glitch we had with audio. I hope everybody's been able to hear me since I reconnected. I'm going to stick around for the Q&A at the end, but I'm handing it over back to Ray now.
Excellent. Thank you, Patrick. And good morning, good afternoon, good evening to everyone. My name is Ray Levy. I'm Principal Application Engineer at PTC, focusing on Kepware and working a lot with our strategic customers that are oftentimes looking at going on this industrial transformation journey. And I just want to take a couple minutes to talk about two customers that have started their own journey, discuss some of the challenges that they have, technical and business, and how KepServer EX has been able to enable them to move forward on their journey. So our first customer is a global leader in filtration components with operations in 15 to 20 different plants worldwide. Their products are used in a variety of different end user markets that include automotive air filters, for instance, or filtration components for food and beverage production as well. Now, while they've standardized at the enterprise level on a common MES, what they also have is a variety of the automation components that Patrick was sort of alluding to earlier, where they have large installations of a variety of different PLCs and devices, as well as in their industry specifically, a lot of injection molding machines to have a part of their manufacturing process. So when we talk about their challenges, what we're really one of the major challenges they have is looking at their equipment that they have that isn't connected and trying to get those connected to their network to be able to digitize or get that data. And their focus has been primarily around their injection molding machines, which uncommonly are very uncommon with being connected into your integrated MES systems. One of the things they did is, understanding what their global competitors are doing, they've noticed that a lot of their competitors also don't have these machines connected because they're often islands of operation, and data is typically only accessible through manual means, whether it's operators inputting data into Excel, for instance, for this customer. And of course, having a variety of plants, you see a lot of variety in different PLCs from different vendors, depending on the regions of the world they are. So whether you're Siemens in Europe, Allen Bradley-based components in the US and the Americas, as well as Omron and others in their Asia specific regions as well. And then another is as part of this journey, they do have a vision to leverage analytics in the future. So they have a roadmap for that, but they don't have a vendor currently identified. So, their challenge is making sure that whatever solution or whatever approach they're taking to connect up their machines, to digitize the data from these machines, then it needs to be flexible and accessible from a variety of different applications. Now, on the business side, their plants specifically make a lot of the same product in different countries or at different facilities. So what they want to do is help compare performance across different plants that are building or manufacturing the same products. Their goal is to really be able to leverage this information to do knowledge sharing between the different facilities, and also understand operational parameters might be better used at other plants if a facility maybe has a better process specifically for that component. In addition, because a lot of their data has been manually accessed and recorded for these injection molding machines, there's been a lot of slow reaction time to either the operations getting outside of normal operating parameters, or to be able to react to any sort of failures or downtime specifically around their operations. So if we look at the approach that they are taking, they came to Kepware to really talk through how they could start integrating this data into a common connectivity layer, so that they can bring in these islands of data that are available at the machine locally into their overall MES solution. So what this has allowed them to do is to be able to integrate not only these injection molding machines using what's called a Euromap 63 interface. They can also leverage the same common connectivity layer to integrate machines and data from their assembly processes as well, which are your much more common PLC or traditional operations devices that you're going to have. So that's allowed them to standardize and simplify the connectivity layer, and give them the ability to now see the performance benchmarks and be able to compare the performances between those two different multiple plants, eliminate the quality issues and the extra time to manually do data collection. It allowed them to be able to monitor their machines and processes in real time, so they can have quicker response times to failures. Now, what this has also been able to do for them is to help future-proof their approach moving forward as they start bringing in future use cases, such as the analytics roadmap that they do have as a corporation. So it allows them to be flexible with being able to choose an analytics package or an approach for their particular operations, and allow the data to be accessible through the many standard interfaces that Kepserver EX does have, whether it's OPC UA or MQTT, et cetera, through those tools. So now let's go to the second customer that I'm going to speak about today. Is they're a global leader in Polymer Solutions, which really means that their facilities operate in a very high volume and variance environment. They have products that are really what they like to say. Their products are available anywhere from applications in space all the way down to the seabed below the ocean. So you're going to have stuff in aerospace and oil and gas, boots for automotive components like on CV joints, for instance, pipe seals and repair kits, as well as maybe even rubber sheeting that they produce. Because of this variety, and their scale at the 120 plants that they have worldwide, this has led them to a scenario where they have a wide variety of automated controls equipment as well as business systems. So unlike the first customer we talked about, they don't have a standardized MES layer or ERP layer. So when we look at their challenges, we're really looking at that high diversity environment across all of their facilities because of that lack of standardization. And actually, specifically with this customer, they started their journey off a couple of years ago by doing a survey of all their facilities to find out more about what they called the maturity levels of their particular facilities. This would be trying to assess the machine connectivity that's currently in place, how the data is being used today at these different facilities, what tools and systems that they do have. And what they came across was, in my perspective, quite fascinating, where they found 14% of their machines were connected to the network, which is a very low number compared to the amount of equipment that they do have across those facilities. And 83% of their key data points that they were collecting across the board were actually being collected manually and not through any sort of automated fashion. So you can imagine that this was a huge challenge, and you know, really puts a damper on them to be able to expand or implement any sort of improvements to their operations. So they came in with a focus of adding visibility to their production equipment because of the lack of connectivity to these machines, because of the large volume of facilities that they do have. They have a very decentralized decision-making process where, as the IIoT program manager stated to us, that it's essentially like operating a bunch of small businesses because of those different business systems and different facilities and different PLCs and hardware, which is, you know, very common across all sorts of different industries throughout the globe. And ultimately, this is sort of going down a path of trying to help set up some common and best practices across their enterprise, which isn't being done today. So when we look at their approach, you know, they're taking that same first step that we've been focusing on, is standardizing on that connectivity layer to be able to help simplify accessing that data. And one of their key focuses and benefits that they found out by leveraging Kepserver as a tool to standardize on the connectivity layer, it allows them to produce a reproducible pattern for any of their future projects or future roadmap, or as they're implementing this across their 120 different facilities. And as they've done this, they've gone through some of their initial projects that they started, which they called production intelligence projects. Their first projects were very simple and straightforward. It was around providing operator displays that didn't exist on the facility floor today, centralizing the OEE calculations and visibility so that there's standard metrics across their factories, as well as being able to provide machine status and production status globally across their different factories as well. So by taking these early initial steps, by simplifying the data collection with a standard connectivity layer, they've been able to see a couple of the things that came out from their results were yield improvements from scrap reduction due to just simple monitoring and simple analytics of their rubber production at a couple of facilities that they've implemented this in. Energy savings, just being able to monitor the actual energy usage for their machines. So they've been able to save money by reducing their energy usage profile. And then additionally, just from adding visibility to their process that they didn't have before, they've been able to gain what they call the sort of a deeper understanding of their processes and find influencing factors to their processes and how the efficiencies of that processes are influenced by things that they never would have picked up on previously. So just having the visibility has been able to gain them efficiencies out of the gate because of the lack of visibility that they had before. So I hope these are two, good use cases just to give you guys an idea of, starting off with getting connectivity to your machines or your systems is usually one of the first good steps on this industrial transformation journey. And there are a lot of benefits to standardizing that layer as much as possible to expand your future usage of that data, to be able to come up with architectures and a software stack that can be reproduced and used across multiple factories, and simplify the implementations going in the future as well. So I appreciate everybody for your time. At this point, I'll pass it off back to Mark for questions and answers.
Great. Thanks, Patrick and Ray. very much for your presentations. We do have time for some questions. The audience may type their questions for the presenters in the Ask a Question box on the screen, and we'll get to as many as time allows. Questions that we don't get to today will be posted online at controleng.com with the archived version of this webcast. Please download a certificate of completion or a copy of the presentation by using the Event Resources tab on the left side of your screen. And now we'll get on to the Q&A. Let's see, Patrick, we're a mess of different systems in our factory, which is one of the topics you address. Different PLCs, different control systems. Given that, how do we even begin to tackle this task?
Thanks, Mark. It's a great question and one that we hear a lot. We've seen companies kind of overreach, and we've seen companies start out a little too slowly here. Our recommendation is generally to start with something a little bit boring, but really fundamental to what needs to get done, which is a kind of system-by-system assessment of capabilities, protocols supported, et cetera. Building those out, building out that kind of database, or even if it's just a spreadsheet of capabilities, really provides a fundamental building block for a lot of what else needs to be done. It's hard to make a decision on what protocols you want to use for communications unless you know, for example, the protocols that are supported out by the systems in your plant. So that's normally where we tell people to get started. And it's a humdrum and kind of boring project to do, but one that we strongly encourage people to get to.
Great, Patrick. You also mentioned IT and OT convergence a few times. Are there best practices for how to bring those teams together?
Yes. In fact, again, this is another area where we have seen companies kind of make a mess of it by just cramming everybody together under an executive, right, or a digital transformation executive. In fact, we recommend companies start a little smaller here, that they build a cross-functional team to begin with that has representatives from IT and OT to tackle a specific project and kind of incent them with the same goals. It could be the project I just talked about of building out your a database of your capabilities, or it could be the next level up, which is starting to define your enterprise data model. Once that team is working together and they start to see the expertise and benefits on both sides, then it's easier to make the next step and start converging the organizations more speedily.
Great, thanks. Question for Ray. What should I be assessing to determine what hardware and software I need to connect to a machine?
Oh, yeah, that's So whenever I'm working with customers, oftentimes they're looking at trying to make these connectivities possible, right? We're really the boots on the ground at this point. So what I always start off with just the basics of connectivity to the network. You know, is the asset or the PLC or the device connected to a network of some sort, whether it's an Ethernet-based network or a serial-based network? From there, we can usually talk about the options of being able to leverage maybe a software solution like Kepware to be able to pull in that data. Otherwise, if it's not already connected to a network, that's when you start going down the rabbit hole of what type of interfaces does that have, again, serial or Ethernet based. What does the facility or the locations have for networks already available? You're going to have a wide variety of different maturity levels of the equipment that's installed at your facilities. So I've worked with customers that have in one facility great gigabit-based Ethernet drops ready to go, and they just need to run some Cat5 or Cat6 cable to connect a machine to their network. Other places don't have that IT or that network infrastructure available, and that's where I would recommend pointing towards some sort of wireless technology, whether it's Wi-Fi based or otherwise, to be able to interconnect the assets within a location to allow you to quickly connect the machines without spending a lot of time on building out infrastructure and running cables, et cetera. So those are a lot of the places to start when we're talking about just trying to connect machines or assets. And then otherwise it's diving into, what's the make and model of the PLC or device that you're working with, what sort of application protocol does it use, and sometimes you might need some hardware translation, but those are the types of topics I focus on when I'm working with customers.
Yeah, I couldn't agree with you more there, right? It's something that we see people kind of, they see this kind of research and they assume, oh, we can't even get started there. We don't even have our machines connected together, right? So it is a more common scenario than most people think, that the connectivity alone, the fundamental kind of physical connectivity, hasn't happened yet in these plants. So focusing on kind of the nuts and bolts is a great place to start.
And a good follow-on question to that, Ray, how can I monitor a machine or a system that has no automation or PLC?
Yeah, so when customers I've seen go the full gamut of options, ultimately you need to digitize the data, and if you have non-smart or dumb machines, you have to sort of put your engineering hat and figure out ways to digitize that information. And I've had customers implement solutions with a Raspberry Pi and some sensors. I've had customers leverage, low-cost industrial PLCs from, every manufacturer has some sort of, low-cost solution that you could tie sensors to. One of the customers I worked with that's in the aerospace that has a lot of CNCs leveraged some lower cost micrologics devices and hooked up some sensors that use serial Modbus interfaces on them, so they could put temperature and vibration and sensors on these cooling auxiliary systems for their CNC setups. And it's a fairly low cost. For them, I think it was around maybe $1,000 for a good enclosure, ruggedized with all these sensors per machine, and for them it was valuable to be able to monitor the cooling auxiliaries that they had no insight into at all, to make sure that the CNC is running optimally.
Good. Patrick, is there a CIO influence increasing among companies of a certain size or in certain segments? Do you think IT is having more or less influence?
So if this is referring to the whole IT-OT convergence thing we're talking about, and the CIO now taking operational responsibility as well, we are seeing some very specific trends in that space. So first, in terms of company size, we're seeing the companies between 1 billion and 10 billion making the most aggressive moves in this area and seeing the most benefit. They're not so large that they can't turn the aircraft carrier, right? But they are large enough that they've got resources and really an intelligent team in place that they can reassign. So that's one way of looking at it. The other is by industry, and I just did the data cut on this. If we look at kind of broadly batch, process, and discrete, process is behind everybody else. So discrete and batch, although batch is a much smaller sample, are further ahead in terms of IT-OT convergence than process industries. It's interesting to us because the process industries are so good at using data and have been for a long time in terms of simulation modeling, and yet their CIOs really do stay very separate from the operations side of the world. I think that trend is going to change in the next year or two, specifically in process industries, but that's where we are today.
Great. And one more question just to wrap up, and then we'll hit the rest of them offline. What are the most important issues for sources just starting out in this area?
Ray, do you want to go
So if
first
there's
on
a
that one?
beginner in the industry and they're looking to you know do their first project or implement a pilot, how would they begin?
Yeah, if you want to start off, Patrick, I don't mind. I can provide any insight on my side. It's a tough question because there's just a lot of different resources and ways you can go.
It is. I would actually kind of
hark back.
I would hark back to something I said earlier, which is, you know, one of the differences we're seeing between the companies that are leading the way and seeing achievements in this space and the companies that are following is kind of their purpose for doing this, right? So I would be very careful if you're just starting out, not to just start playing around and kind of testing the technology to see what could happen, but really kind of take that step back and figure out what is it we wanted to deliver for our business? What's our purpose in doing this? What's our goal? You know, 1 year, 3 year, 5 year goals for pursuing plant connectivity and the kind of the digital plant, and really let everything fall out from there. That's this kind of fundamental starting point for me.
Great.
Yeah, that's
well. Thanks.
That would be one I would. Oh, I'm sorry. I meant to say I would agree with that. Focusing on use case and driving your needs from there, and basically from that business, business optimization or business benefit is a great approach.
Excellent. Well, thanks everybody for the great questions. We'll get to the other questions offline. And thanks again to our great speakers, Patrick Fetterman with LMS Research and Ray Levy with PTC for sharing their time and expertise. I'd also like to extend special thanks to our sponsor, PTC, for sponsoring today's event. Now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use the information to improve our future webcasts. And finally, on behalf of Control Engineering and CFE Media and Technology, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.